In this video, we're going to talk about standard enthalpies of formation and specifically how to use them to calculate standard enthalpies for reactions. So first off, what do we mean by standard enthalpies? Well, these are enthalpies that are taken under what we call a standard state. And that standard state is referencing the pressure and the temperature that the enthalpies are measured at, right? So standard conditions is going to be 1 atm of pressure and about room temperature, 25 degrees Celsius, right? So at this pressure and temperature, this is what's known as standard conditions, and any enthalpies measured for a reaction at that standard state is going to be a standard enthalpy. Now, formation is referring to the formation of a compound, right? So like when we looked at the formation of methane from carbon and oxygen, right? So what is the enthalpy associated with the formation of that compound? And the way we denote enthalpies of formation is the following, right? So we'll have delta H, but we'll have a little degree symbol in the superscript that denotes standard conditions. And then the subscript, we usually put F to denote enthalpy of formation. Now, essentially what you can do here in order to get a enthalpy for any reaction is envision it in the following way, where you envision all of the reactants being broken down into their elemental components, then those elemental components being used to form the products. From there, you can use Hess's law and build up the following equation that works for any reaction under standard conditions. So if you want to know the enthalpy for a reaction at standard conditions, right? So that's why I put the little circle here. Right? Basically, what you want to do is take a sum, right? So I'm going to use the big sigma summation notation. So this just means taking the sum of the number of moles of your product times the enthalpy of formation of your products. And you're going to subtract that from the sum of the number of moles of the reactants times the enthalpy of formation for the reactants. So typically, right, well, let me annotate this for your notes, right? So this is the number of moles of product. And obviously this one is the same for the reactants, right? So number of moles for the product or the reactant. And these are the enthalpies of formation, right? Specifically the standard enthalpies of formation. Right? And then this is just a sum, right? So just saying you're going to add up the enthalpies for all the products and then add up the enthalpy of formation for all the reactants. And you're going to subtract those two, and that'll give you the enthalpy of a reaction under standard conditions. And so this is really useful. If you look at the back of your textbook, whatever textbook you're using, most likely has a enthalpy of formation, standard enthalpy of formation chart. And you'll have a bunch of different molecules that have the standard enthalpies of formation. So you can always look at that chart, and if you're doing a new reaction or trying to figure out something about a reaction, then you can use that data in order to calculate the enthalpy for that reaction. So let's look at a quick example of putting this equation to the test, right? So, what we have here is the enthalpy of, we want to calculate the total enthalpy change for the following reaction. Again, dealing with the combustion of methane, right? And it says you want to use the following standard enthalpies of formation. So they've given us the enthalpies of formation for methane, for CO2, for H2O, right? Now, one thing I should note about standard enthalpies, if you have something that is just an element at standard conditions, so let's say O2 or N2 or helium or H2, right? These things that are only one element at standard conditions, their enthalpy of formation is 0. Right? And that should make sense because you're not forming anything. It's just naturally is just naturally this one element under standard conditions. So its enthalpy of formation is always 0. So our enthalpy of formation for O2 in this case will be 0. Outside of that, we're going to apply this the equation that we saw on the previous page in the exact same fashion, right? So in this case, the enthalpy for this reaction, standard enthalpy for this reaction, will be the enthalpy of formation for CH4. Oh, wait, products minus reactants. So starting with the products, delta H of formation for CO2, right, plus the enthalpy of formation for H2O, right, actually 2 times the enthalpy of formation. Right, because keep in mind, if we look back at the original formula, right, you're taking the number of moles of that product times its enthalpy of formation, right? So if we look at this balanced equation, we have 2 moles of water, so we're going to multiply this guy by 2. Now that's going to be minus the enthalpy of formation for methane and minus the enthalpy of formation, 2 times the enthalpy of formation of O2. Right, so this is applying this Hess's law for standard enthalpies of formation. Right, so all we have to do now is just plug in all of our enthalpies of formation in order to solve for the standard enthalpy for this reaction. Right, so we have our enthalpy of formation for CO2. Right, this was given to us here. Right, so that's going to be negative 394 kilojoules per mole. Now we were given a standard enthalpy for water, right? Our second product, and we just have to multiply that guy by 2. And so that's going to give us negative 572 kilojoules per mole. And for the reactants, right, we're going to have negative, right? We're given the enthalpy of formation for methane. That's going to be negative 75 kilojoules per mole. And like I said before, the standard enthalpy of formation for any standard element, right, in this case O2, is going to be 0. So we just have 0 at the end, right? So when you add all this up, right, negative times a negative is going to be a positive there. And then you add up all these numbers, we get negative 891 kilojoules per mole. And that's going to be the enthalpy for the enthalpy of the reaction at standard conditions, right? So using these standard enthalpies of formation, you're able to solve for the standard enthalpy for reaction using a combination of these standard enthalpies and Hess's law.